Hello, my name is Skrill, also known as Discord user Buzz, and today I would like to present you the Sane Rendering Manifesto. So what is the Sane Rendering Manifesto? I think the modern rendering has gone too far and we need to stop for a minute and think about what we are doing. The manifesto proposes a short set of rules that graphics engineers can follow, and these rules have a few specific goals in mind and help to achieve these goals. First goal is we need to prioritize image clarity and stability over excess fidelity and photorealism. We need to start a wider discussion on the state of the modern real-time rendering in general. It's also a call for action to search for alternative solutions and technologies that will suit video games better. And last but not least, I would like to be inflammatory and challenge the status quo as much as possible. As of today, there are 3 rules. First rule is do not use dynamic resolution. Second rule is do not render at lower refresh rates. And the third rule is do not use temporal amortization. So, why not use dynamic resolution? Because fractional upscaling makes the game looks bad on most monitors, especially if the scale factor is changing over time. It introduces pixel swimming artifacts and generally looks unpleasant. It also creates a false sense of security for the game developers. For example, I've heard multiple times that we can always drop 10% of resolution later to make up for some performance issue, and it never works that way, and it always creates more problems down the line. So what is allowed under Rule 1? Integer scale factors that matches the monitor resolution exactly after upscaling. It's also allowed to render at lower resolution internally but output to native resolution with a point or nearest filter. However, the scale factor should be fixed and determined by the quality present in the settings. What is not allowed? We don't allow adjusting the scale factor dynamically at the runtime. We don't allow fractional scale factors, and in general any integer scale factor that doesn't exactly match the monitor or TV resolution after the upscale. It's also not allowed to render opaque and translucent objects at different resolutions because they will look bad. And here are a few implementation recommendations. So easiest way to do it is to render to an internal low resolution render target, which is followed by blit to the native swap chain resolution with a point and nearest filter. Do not use a linear or any other filter. It's also allowed to render at the low resolution render target and then do integer upscale and then do the post-processing or any other post-image effects at native resolution, which will look a little bit better, I think. So rule number 2, do not render at low refresh rates. Low refresh rates under 60 Hz increase input latency and make the gameplay experience worse for the player. It's not about the smoothness of the animations, it's primarily about the input latency. So what is allowed? It is allowed to render at 60 Hz in case of a high refresh rate monitors, for example 90 Hz or more. It is always allowed to render at the highest refresh rate the hardware supports, even if it's lower than 60 Hz. For example, there might be an incorrect cable or hardware configuration, or the user explicitly configured power saving profile to limit the games to 30 Hz. Offering alternative graphics presets to reach target refresh rate is also obviously allowed. What is not allowed? Explicitly targeting 30 Hz refresh rate during development or using any kind of frame generation. Frame generation does not improve input latency, which is the whole point of having higher refresh rates. And then the recommendation is, first and foremost, decouple your game logic update from the rendering code. There are multiple articles on how to do that. I will not focus on specific details here. You can use GPU-driven rendering to avoid CPU bottlenecks in case you're CPU bound. Try to target native monitor refresh rate and use the allowed integer scaling methods to match it. And also, to further reduce the input lag, use vendor-specific low latency input libraries that every hardware vendor provides. Rule number 3, do not use temporal amortization. It's pretty simple, really. If you cannot compute something in the duration of one frame, then you need to stop and rethink what you're doing. You're making a game, you need to make sure that the game looks great when the camera is moving. I'm sorry, but nobody cares about how a game looks on static screenshots if it falls apart in motion. Nobody cares about photorealism and extreme fidelity, so try more interesting art direction to make up for that. And especially important is that in many cases bad TAA or unstable temporally amortized effects like clouds, it's an accessibility issue that can cause health issues for your players. People get nauseous, sometimes people get seizures or getting generally uncomfortable to play for extended periods of time, and this loses your money because this loses your customers. So what is allowed? Ray tracing is allowed as long as the work is not distributed across multiple frames. Any kind of lighting or volume integration is allowed as long as it can be computed or converged during one frame. Variable rate shading is allowed as long as it does not change the shading rate based on the viewing angle and does not introduce more aliasing. What is not allowed? Reusing view-dependent computation results from previous frames. TAA, including AI-assisted TAA. TAA never looked good in motion in the first place. Even with AI, it breaks on translucent surfaces and particles. And in general, the industry, both game companies and the hardware vendors and the game engine vendors have spent millions, if not billions of dollars and many years on trying to improve the situation, and it still does not work. Also, it's not allowed to try to interpolate or denoise missing data in case of disocclusion or fast camera movement. For example, if you are doing a raster-based screen space probes and you encounter a region where the probe has not been spawned yet, it is not allowed to assume that the probe will be spawned at some point in the future. So what are the recommendations? Pre-filter your roughness textures with VMF filtering. You can use AI-based tools to generate better level of detail and better meat maps. Again, there are multiple articles with multiple different approaches and solutions to that. You can use AI-based tools to assist with roughness texture pre-filtering. You need to enforce consistent textile density in the art production pipeline. You need to enforce triangle density constraints in the art production pipeline because both of these contribute a lot to aliasing. I realize that this is probably very hard to follow, but my next slide is, let's start this discussion. There's a gist link in the video description where you can find this manifesto, and you are invited to comment and suggest more ideas and start a general discussion. I want to be constructive and I want to provide actionable items. So first of all, I'd like to discuss AI-assisted specular aliasing solutions. It sounds pretty straightforward at a glance. You can take a super sampled image as an input and train the AI to filter it to match the reference. So this is not unlike the VMF filtering that was mentioned previously. I think it's probably doable. Let us discuss stable global illumination that can be computed in one frame. What kind of trade-offs are we comfortable with? I would not want to sacrifice image stability, and as we've banned the TIA, then we need to compute it in very fast. I think we could start with LPV and see how far we can take it with ray tracing, but again, I'm open for more discussions and I would like to start generating ideas on that. There hasn't been a lot of updates to subpixel morphological anti-aliasing. Maybe it's time to revisit it as well. Also, if you want to call me an idiot, then this is fine, go ahead. I realize that I'm contradicting literally all modern rendering practices, and I expect some level of heat towards me. Thank you very much, and thank you for your time.